Alright guys, this video is about acid and basic properties of salts. This table will help us understand why some of the salts are basic, some of the salts are neutral, and some of the salts are acidic. Let's use those examples to demonstrate how we use this table. First one, sodium carbonate. Sodium carbonate is a strong electrolyte. When you dissolve this salt in water, it will give you two equivalent of sodium cation and one equivalent of carbonate. Okay. And when you look at these two ions, sodium is from a strong base, sodium hydroxide. So it looks like we should go to number 1 or number 3. The anion, carbonate. And if you remember those common strong acids, carbonate is not any one of them. So it's not from a strong acid. Therefore, pH of this salt should be higher than 7. Now, how do we understand this salt is a basic salt? It's because of the carbonate is a very weak base. It will interact with water to generate bicarbonate and hydroxide. So bicarbonate, HCO3 minus, and hydroxide. So hydroxide will make this salt a basic salt. Example B, ammonium nitrate. Ammonium nitrate dissolves in water to give you ammonium cation and nitrate. So again, when you check those two ions, ammonium is not from any one of the strong bases we remembered. So it looks like we should go to either number 2 or number 4. For nitrate, it's from the strong acid, nitric acid. Okay, so it looks like we should check this number 2 because nitrate is from a strong acid. Therefore, this base, this salt, will give you a pH value less than 7. It's an acidic salt. And why does this one choose acidic property? It's because of ammonium, okay, is a weak acid. In water, ammonium will be a proton donor to generate ammonia, an H3, and hydronium. And we know hydronium is acidic. Therefore, the salt ammonium nitrate is an acidic salt. How about example C? Okay, again, this salt will dissociate in water to give you potassium cation and OCl minus anion. Potassium is from a strong base, potassium hydroxide. OCl is not from a strong acid. Therefore, it looks like it's number 3. Potassium from a strong base. OCl minus is not from a strong acid. Therefore, pH of this salt would be higher than 7. Then again, let's talk about why this salt is a basic salt. It's because of the OCl minus 3 will interact with water to generate the conjugate acid and hydroxide. Okay, so here this is a conjugate acid of OCl minus, and this one, and the second product is OH minus, hydroxide. So this is a basic salt. How about D? D, lithium perchlorate. Dissolve that in water, you will get lithium cation and perchlorate. Lithium cation is from a strong base, lithium hydroxide, and perchlorate is from a strong acid, perchloric acid. Therefore, Cation is from a strong base, anion is from a strong acid. Therefore, it's a neutral salt. pH equals to 7. Okay, so this is example D. When you look at the example E, this salt, you have 2 ions. If you dissolve that in water, it will give you CH3NH3 cation and the acetate CH3COO minus. Now, if you remember, this one is not in one of the strong bases we remembered, and this one is not from either one of the strong acid we remembered. Okay, so it looks like we have to follow what we have in number 4. Cation is not from a strong base, anion is not from a strong acid. So in this case, we do have to compare the Ka and Kb value of those 2 ions. And here I give you this Ka value for this weak acid and Kb value for this weak base. And let's follow it here. Because in this case, example E, because the Ka is less than Kb. Okay, Ka is here, Kb is here. Ka is less than Kb. In this case, the pH value should be higher than 7, which means this salt would be a basic salt. So I hope this video can show you how we use this table to decide whether a salt is acidic, basic, or neutral. Let me know if you have any questions.